So good morning all. The last class we were discussing on motion of the lift. Okay, so maximum probability of questions that can be asked in a lift has been discussed, and now we'll go for some small concepts such as work and energy and their relations. Similarly, impulse and momentum. So you don't the questions may not be asked from this part problems may not be asked, but the concepts as per your syllabus you need to understand the concepts. Okay, so what do you mean by work? You know that work is force into distance. Most of them know this formula, right? So what is the force, and in mechanics how will you define work? Okay, so work is said to be done whenever the point of application of a force is moved along the line of action of that force or along line of action of component of that force. That means, see, if consider this object, a force is given in this angle for a theta angle, but the object is not moving in the force that you have provided. It is moving along this angle. So total work done is given by the effect, that means where the object is moving in what distance, that is here ds, into the force used here is the component of this force in the direction of displacement. That means displacement is in this direction, so force, if you resolve it in this direction, what happens? F cos theta into ds. Okay, so this is what discussed here, where theta is the angle between F and A. Now if suppose this is an inclined surface, okay, the same thing, force is applied here, ds is this, but the object is moving here, means this is ds cos theta, F into ds cos theta becomes the work. Okay. Okay, now there are some small concepts. Work is positive when force or component of force in direction of displacement, and negative when it is in opposite direction. That you also know. If you are doing a work, see, if you are giving a force and if it is moving forward, in the direction of force applied, then the work is said to be negative. Otherwise, if you are placing it in an inclined surface, you're giving force, but this object is moving along this side, then the work is negative. And also the work done by a force of gravity is positive when a body moves from higher elevation to lower elevation. It's again another concept that you might be knowing. Work done by force of friction is always negative, because direction of frictional force is always opposite to direction of motion of body, right? See, work done by friction, if this body is moving, then friction is in this direction, so that will be negative always. Okay, so now what is energy? What is the difference between work and energy? That we will see. Energy is the capacity to do work. Unit of energy is same as that of work, that is joule or Newton meter. So generally mechanical energy consists of potential energy and kinetic energy. These all things you know. Potential energy is mgh, kinetic energy is half mv square. Now we'll relate work and energy. Okay, what do you mean by work and energy? So work done by a system of force acting on a body during a displacement is equal to change in kinetic energy of body during the same displacement. So I will explain this work energy principle. This also you might have studied in your +1 physics. So if you are giving a force F on an object of mass m, which is moving in an initial velocity of u, and it moves a distance or a displacement of s with its final velocity v. Okay. Sorry. So from Newton's second law, you know that F is equal to ma, where a is equal to dv by dt. I am just differentiating partial differentiation, dv by ds into ds by dt, which is nothing but dv by dt itself. A is equal to dv by ds into v. Okay. Now F is equal to m into v dv by ds. I am taking this ds to this side. F into ds is equal to m into v dv. So F into ds is nothing but work done, and m into v is change in momentum. Okay, wait. So F into ds means is applying from 0 to, that is work is done from 0 to s, and here velocity is changing from initial to final uv. So F into s is equal to, if you integrate v, mv square by 2 minus mu square by 2. So work done is the change in kinetic energy. This is what the work energy principle tells you. So we'll continue with the lecture with a small problem. Calculate the work done in pulling up a block weighing 20 kilonewton for a length of 5 meter on a smooth plane inclined 20 degree with the horizontal. So given this is a smooth plane, so there is no friction involved. So 20 kilonewton is its weight, and this is displaced to a displacement of 5 meter. So the given data are W, S. You just need to find out the work done, force into displacement. Since this is moving up, this is its direction, W sine 20, sine theta, which is sine 20 into 5, 20 into 10 power 3. This is 34202 joule. Okay. Now, next concept is impulse and moment. What do you mean by impulse? When a large force acts over a short period of time, that force is called an impulsive force. So it's a sudden impact. Okay, large number of force acts over a short period of time. That force is called an impulse force. The impulsive force F acting over a time interval t1 to t2 is defined by the integral. See, impulse is given by F into dt from time interval t1 to t2, where t1 to t2 is very small. Okay. From Newton's second law, you know that F is equal to change in momentum, dp by dt, d of mv by dt. You take this dt here, f dt is equal to d of mv. There is no change in mass. If you integrate both this, change in mass is 0. So f dt is m into integral dv. So applying limit t1 to t2 and here v1 to v2. F of t2 minus t1 is equal to mv2 minus mv1. ft is equal to mv2 minus mv1. So impulse is the final momentum minus initial moment. Unit of impulse is Newton second, because F into t, right? So force is Newton and time is second. Okay, mv2 for momentum, it is kilogram meter per second, because mass into velocity, right? Kilogram meter per second. This can be equal to Newton per second by kilogram meter per, you add and divide second, kilogram meter per second square into second. Kilogram meter per second square is Newton and second is, okay. Now another concept is conservation of linear momentum, that you know, when the sum of impulses due to external force is 0, momentum of system is conserved. That is simply sigma mv1 is equal to sigma mv2. Final momentum of the system is equal to initial moment of the system, or vice versa. So these are the concepts in work energy principle as well as impulse and momentum. Okay, So these theory parts, you just need to know the concepts only. So we'll do some problems on, in the next lecture we'll do some problems on rectilinear translation. Already we have done the motion of connected bodies using D'Alembert's principle and all. We'll do some more problems in equations of kinematics. We'll use kinematic, that means except force, which includes acceleration, velocity things, equations of motion. Using that we'll do some problems in rectilinear motion. Okay, thank you.